Today we're learning to work with scattergraphs. What we'll be doing with scattergraphs today, we'll be taking information from a data table and we'll be drawing a scattergraph with it. On the scattergraph we'll be drawing a line of best fit. We'll be working out the equation of that line of best fit, and then we'll be using that equation to work out some information that we may be asked. Now what I've got here is I've got two examples that we'll work through, and also I want to talk about correlation, which is a key part of scattergraph work that we do at National 5. So this will allow you to do National 5 exam questions after you've reviewed the video here. Okay then, so let's start. So what we've got is we've got some data, and it's about the weights and heights of 10 boys, okay? So we've got the weight of the boys, we've got the height of the boys associated with their weight, okay? So what we're going to do is we're going to just plot that on a scattergraph. So on the scattergraph, what I've done is I've written height for the vertical axis, and down the bottom on the horizontal axis, which is a way down here, if you can see it, way down there, I've put weight in kilograms, okay? So I've labelled that one up W, and what I'll do is I'll label this one up H, okay? If I look at the data though, I've got this data in order so you can see where it's coming from. Normally it won't be in order, but you'll just be plotting the points kind of randomly as they come along. But if I look at the first point, 36.5, 123, so 36.5, 123 is somewhere about here, okay? And if I look at the kind of tallest point, or the biggest one, 44 and 146, there's the plot I'm going to make, 44, 146. So that's going to be up here somewhere. So all of my information is just going to be in that wee box there. So what you usually find in scattergraphs, the graph won't be drawn on this piece of paper here because there'll be so much wasted paper that we won't be using. So what I've done is I've redrawn that. Okay, so this is the one that we're going to use here. So it's a smaller graph. It doesn't start at 0 though. It starts at 35, which is kind of close to the 36.5. It's just rounded. And we've got 40 and 45 out to there. We've got starting at 120 going up the way, because the minimum height that we can see in the table is 123, and the maximum height is 146, so it's going to lie within there. So I'm going to get a better graph, or a better representation, if I graph it on this paper here. Right, so I'm going to try and go reasonably quickly when I plot them. Sometimes in the exam you'll get a scattergraph given to you. You might even get the line of best fit drawn on it, and from there what you'll do is you'll work out your equation from it. Right, let's go and do this. So 36.5 and 123. So this is going to be 36 that's here. So 36.5 is in the middle here, and I'm going up to 123. So I'm going to just put a dot right there, okay? I'm then going to go for 38.0 and 124. So 38 is here, 38, and I'll go up to 124. 124 is going to be there. 38.5, so 38.5 and 127, so there'll be 127 there. I'll go for 39.5, so that'll be 39.5 that's sitting here, and I'm going up to 130, so that'll be on the line there. I'm going up from 40 and 136, so 40 and 136, so that will be 136 will be there. 42.5 and 135, so 42.5 and 135, so that will be here, 135 will be bang on that line that's there. I've got another 42.5, so sometimes the values are the same, okay, but they're separate plots, so you just plot them. So it's 42.5 and 140, so that would be a plot that I would get up there as well. So 44.0 and 142, so 44.0 is here, so that'd be 44 here, and we're going up to 142, so 142 would be here. And the last point, 44 again, and it's going to be 146, so 14, that's 145, 146 up there, okay? So that's me got my plots in place based on the table that I worked out there. Okay, so now the point you've got to go for is to draw the line of best fit. So what we're looking for is to draw a line that's through this information, and we're trying to split the information, the same number of dots on one side of the line as the other, okay? So, and what we're looking at is the relationship if we're low on this axis here, so there's low on the axis, we look to be low on that axis there. If we're quite high on this axis here, we're quite high on that one there. So we've got a trend that's happening here. So let me fill in some other information on the chart that we've got here. So this here is going to be the weight, this one here. So this was the weight. And what we'll do is we'll call that axis the W axis. Okay. This one here was the height. So that's height. And we'll call that the H axis. So the height was going to be in centimetres and the weight was going to be in kilograms. Okay, so that's me got that chart kind of set up basically for this, okay? And it's just the height and weight. So it's the height and weight of 10 boys, okay? So it's would just be our basic title for the graph. Right, before I draw the line of best fit, I want to talk about correlation. Okay, I'm going to come back to this page in a minute. Right, so correlation, a key point. And what I've got here is there's a similar graph to what we've just drawn on a different scale. With the scatter graph, it allows us to see that there's a connection between the 2 points or the 2 data sets that we've got there. And connection, I mean there's a relationship between the two, okay? So what we've got here is that we can generally see that the taller a boy is or a person is, the more weight they'll have. You know, they should be heavier. So for weight and height, generally, if we were to plot that for the population, we would see a graph that would look something like that. Now, if I think about the relationship between 2 data sets, it's called the correlation, okay? If I look down here, I've got a couple of different graphs that I can show you that will talk about correlation. So if you think about gradient, remember the gradient of a straight line? If it's going from left to right, up the way from left to right, then that's a positive gradient. So we call that a positive correlation, okay, for that there. And that means that when one variable, you know, if I call that a variable that's along in this axis here, so one variable increases, the other one also increases. So what we get is a positive correlation. At the far side here, we've also got a negative correlation. So what that would be is if one variable increases, so we're getting bigger or higher on that axis that's here, the other decreases. So we've got a negative gradient or a negative correlation, as it's called when we're talking about scatter diagrams. Right, so we can also have a zero correlation, and that would mean that there's no direct correlation at all that we can see from a linear point of view. So there's no linear relationship at all to the information that we're plotting. So you just get dots anywhere. So no matter if I'm high on this side, I might be low or high on the other axis when I plot my points, okay? So I'm saying that it's a linear relationship. There might be a different relationship that you'll come across when we work at maybe some other topics at National 5 and also topics at higher maths. But the thing is, as the points get closer to being a straight line, if I look at this part here, the closer they get to being a straight line, the stronger the correlation is. So it can be a strong positive correlation if they're very tight, or it can be a really strong negative correlation if it's going down the way. So that's correlation. And sometimes you're asked a question based on that to identify what the correlation is between the data set. Right, back to the question that I was doing, okay? So what we're going to do here is we're going to draw a line of best fit through the points that we've just plotted. So usually what you're doing, as I say, you're going to try and get your ruler and you're going to try and draw a line through as many points as you can, leaving the same number of points on the upper part of it as the lower part of it. Now, I could probably put my ruler across there, and what I've got is I've got probably 1, 2, 3, 4 points that side, 1, 2, 3, 4 that side, but you can see definitely that there's a trend of data and it's going in that direction there. Right, I'm going to show you the way that I would work this out. If I've got time or if I've got a calculator I'm working this type of question with, then what I'm going to do is I'm going to find the mean point in between all this data. So what I'm going to do is I'm going to go back to this table up at the top. What I'm going to do is I'm going to add all of these numbers up for weight. So if I add all them up, I've already done that. So what I've got is 40, so the total is 406.5. Okay, that's my total that's there. I've got 10 readings, so if I divide that by 10, what I'm going to get is I'm going to get a mean value. Okay, so the mean value there, if I divide this by 10, moving the decimal point one place in, I've got 40.65. Okay, and if I can call that just 41 for ease of working out some of the things that we're going to be doing, just for ease of it. For the height, if I add all the heights up, what I'll get there is I'll get 1339 if I add them up. Divide it by 10, and what I get is 133.9. Okay, and if I'm okay to round that as well, I'll round that to 134, if that's okay with you guys. Okay, so 134, and what that is that gives me a mean point that I'm just going to plot on the graph. So 41 and 134, so 41, so this is 41 here, so that's 41. Okay, and I'm going to go up to 134, so 134 is right there, so that's the point there. Okay, that there is my mean point, and the coordinates of that mean point we're just going to say it's 41 and it's going to be 134. Okay, that's that point there. So what that gives me, it gives me a point where I can try to swivel my ruler around, you know, that point there. So what I want to do is to keep it on the mean and swivel it round there so I can get it through the data set. So if I stop about there somewhere, so what that would tell me is if I look at one side of the data, so how about there somewhere? So I've got about 1, 2, kind of 3, 4 points just kind of poking over there. I've got 1, 2, 3, 4 kind of poking there, if you can see that over the top of the ruler. And all I'm going to do is draw a line that's going to go all the way through these points that are there. So I'm going to do that, okay? So we were about here and here. So I'm going to just draw a line all the way through there. Something like that there, wasn't it? So just about there somewhere. Right, so what I'm then going to do from there is I'm going to work out the equation of this line. So I'm going to take 2 points, so I could take the mean point, so that's quite a good one to take, and any other point that's on the line. It doesn't have to be an actual point that you plotted from the table, but it just needs to be one of the points that we're going to use. I'm just going to use that one there, okay? So that's going to be the point 38, and I've got, let's see, what's that, 124. Okay, so they're the 2 points I'm going to use to work out my gradient. So remember what I have to do after that. I'll be asked to find the equation of the line of best fit. So let's go and work out our gradient based on that. So my gradient is y2 minus y1 all over x2 minus x1. So remember, I've got the points up ahead. I'm going to choose 134 for my y2 minus 124. I've got 41 and I'm going to take away 38. Okay, so if I work that out, what I've got is 10 on the top and I've got 3 on the bottom. So there's my gradient. I can't simplify that anymore, so I'm going to leave it as 10 over 3 as a gradient. So I'm then going to use, let's use 2 different methods of working out the equation of the straight line based on the work that we've been doing. So what I'm going to do, this one here, I'm going to be using y equals mx plus c to work this out. So the first thing that I'm going to do is I'm going to use one of the points. So I'm going to use this point here. Let's just use this one, okay? Or why don't we use the mean? You know, if we use the mean, it works out quite well because we know that that's the average of all of these points that's here. Right, so for y, I'm going to use the 134. So 134 is equal to my gradient, which is 10 upon 3, which I worked out. The x value for that coordinate is 41. And we've got a plus c going on there. Right, from there, what I can do is I can work out this part here. So 10 over 3 times 41. Remember, if I'm working out fractions, just multiply straight across at the top. 410 all over 3. Okay, so what I'd like to do is to change this round. So I've got c on the left-hand side. So I've got 410 all over 3 plus c is equal to, and what I'm going to do is for this one here is I'm going to change that into thirds. So if I change it into thirds, I can times it by 3, and what I should get is the amount of thirds that is. So 3 times this number here, 3 times that's going to give me 402. So that'll be 402 all over 3, because that's the exact same as that number there. If I simplified that down, I would come back to that number that's there. Okay, so I'm working in thirds, so C value is equal to, so I'm going to subtract from both sides. I'm going to subtract 410 thirds, and I'm taking 410 thirds away from this side as well, okay, just to balance it up. Remember what that does, eliminates that part there, leaves me with C is equal to, and that will leave me with negative 8 over 3. So there's my C value that's lying there. So all I'm going to do is write that into this equation that's here. So I've got my equation generally is that there. So what we'll do is we'll get y is equal to my gradient, which is 10 upon 3, x, and it's minus 8 upon 3. Right, so it's at this point you need to really be very careful, because a final mark here is to make sure that you change the formula around to use the letters that you have in the graph. So remember, we've got weight as W and we've got height as H. Okay, so what I'm going to do is here, I'm going to change that to H is equal to 10 upon 3, and instead of X, it's going to be a W minus 8 upon 3. So there's my equation. This one here, equation of that line of best fit. Okay, so now I'm going to use that line to try to calculate something. So use your equation to estimate the height of a boy weighing 42 kilograms. Okay, so that would be the W is equal to 42. So that equals W. So I'm going to substitute that into this equation that we're starting off with. And here we go. So 10 upon 3, I'm going to multiply that by 42 and take away 8 upon 3. Okay, so when I work that one through, what I've got is multiply that across the way, 420 all over 3 times the 1 that's sitting there, 3 times 1, and that's take away 8 upon 3. So what we've got left with is 412 all up in 3. And let's see, that won't simplify down any further. I can't get that simpler, so I'm just going to use that as it is. So that's going to be, that was the weight, so he's going to be that height. So he's going to be centimeters tall for 42 kilograms, okay? If I did want to divide that out, 3 into 4 goes once, okay? That'll go 3, that'll go 7 point, and it's going to be 333, so that's going to be into third centimeters tall. Okay, so if I wanted to do it that way, okay? Right, so that's this one completed. That's the first one done. Right, so what I'm going to do next is go do one more example with you, and that'll be us finished. So we've talked about correlation. If you were thinking that what we could do is just go back up and read the values off the line, well, that would be okay for National 4 work, but for National 5 you must use the equation. Okay, so with this one here, what we've got is we've got a table that's for the fuel consumption of a group of cars, you know, in here. So what we're going to do is we're going to draw the scatter graph based on that information that we've got there. Right, so let's go ahead. So again, what I've done is I've cut this axis here, so the axis doesn't start at 0, it's starting at 7 basically that's there. And this axis here does start at 0. So this one here is my engine size. Okay, that's the engine size down here, if you look at that one. And the engine size, we're going to call that E for that one there. And the engine size is going to be in litres, okay, for a car. What we've also got is the fuel consumption up at this side here. So this is fuel consumption. And that's going to be in kilometres per litre. Kilometres per litre, okay? Right, so from here, what we're going to do is we're going to take the information from the table, and we're just going to plug it into the graph that's here. So for a 1 litre car, we'll get 16. So 1 litres, we'll go for 16 kilometres per litre. For 3.5, so 3.5's there, we get 9. Whoops, that's down there. For a 5 litre, a Mustang maybe, I don't know what that one would be. 5 litres, we're going to get 8. So so a 5 litre car. We've got a 3 litre car at 11, so 3 is going to go 11. We've got a 1.5 litre at 17, 1.5 at 17, and that's going to be kilometres per litre, so a fuel economy. 4 litre is going to be 10, 4 litre 10, that'll be there. We've got a 2.5 litre at 14, 2.5 litre at 14, up to there. We've got a 2.5 litre at 14 as well, 2.5, oops, that was a 2.5 litre at 14. Yep, okay. We've got a 2 litre at 13, 2 litre at 13, so that'll be there. And we've got a 4.5 litre at 10, 4.5 litres, and we're going to go for 10 on that one there as well. So 4.5, and that's going to be 10. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 points I've got, yep. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I've got 9 cars, so that works out. That's not bad. Okay, so what we've got to do now is to draw a line of best fit. So what I would do again is to work out the mean point, okay? So it's not a necessity to do this, but it always gives you a place where you can revolve your ruler around when you're trying to draw your line of best fit. So if I add all of these up, okay, I come to 27. I'm going to divide that by 9, okay, because that was a total. Divide by how many readings we've got, and that should give me a value of 3 for the mean. So that would be the mean engine size that we've got there. I'm going to add all of these up as well, and what I should get there is 108. I'll divide that by 9, and what that will give me is 9 into that will give me 12. Okay, so there's the point I'm going to plot. So the mean point on the graph is going to be 3, 12. So if I go 3 along, okay, 3 along, 12 up, so that's going to be this point here. So that's where I'm going to try to revolve my ruler around, and that was 3, 12. And I'll maybe use that in my calculation as well. Okay, so let's get a ruler. So if I try to use my ruler here, and if I try to see which way the data is trending, so I can see it's trending in that way, so the correlation is going to be negative if I look at this, because it's like a negative gradient. And let's see what I can do if I can try and swing the ruler around to, say, that point there. Let's see, what have I got? I've got 3 on that side, 3 on that side, and I'm kind of going through 3 of these points. That looks quite good to me, okay? So what I'm going to do is I'm going to draw my line straight through these points here, okay? So that's going to be my line that's there, okay? So that looks quite good in terms of the line of best fit. So if I pick a point on here, so I could pick that point down there and use that, so that'd be 5 and 8, 5, 8, or I can use some easy numbers, 1 and 16. Let's go for that. We'll go for the 1 and the 16 to try to use these ones here. Right, so what I'm then going to do is I'm going to work out my gradient. Okay, so my gradient is equal to y2 minus y1, x2 minus x1. And we should expect a negative number coming out of this because it's a negative gradient. So I'll just write down the points that we're going to use, because I know that we're just off the scale here. 116, and we're using that mean point, which was 312. So I'm going to work out my gradient first. So my gradient is equal to y2 minus y1 all over x2 minus x1. Okay, so from there, what I'm going to go for is I'm going to go for 12, take 16, and I'm going to go 3, take away 1. Take away 1 from that. And we'll see how that one's going to work out. Okay. Right then, so if I've got 12 take away 16, that's going to give me a negative answer. So that'll be negative 4, and that's going to be 3 take away 1 is going to be 2. So that will give me a gradient of negative 2. Okay, every time I move along one place, or 1 litre, I'm going to be going up 2. Okay, or down 2, sorry, down 2, because it's a negative. Right, so then I'm going to substitute. I'm going to use my first equation. That's going to be my A value and my B value, my first coordinate, and that's my gradient that's there, a negative 2. So I'm going to substitute, the point 116 and my gradient of minus 2 into the general equation of that straight line, or the y minus b is equal to mx minus a. So I'm going to have y minus, and we're going to take away the 16, because that's what the b value is. My gradient's negative 2, x minus the a value, which is 1. Okay, so I've got some nice easy numbers to work with there. That's good. So here I've got y minus 16, multiply the bracket out on the right hand side, negative 2 times negative 1, two negatives together, multiplied, that will give me a positive 2 value that's going to be there. Right, so all I need to do now is take 16 from both sides, and that will eliminate this one here. And when I eliminate that, that should leave me with y is equal to negative 2x, and that's going to be, so I'm going to be adding there. I hope you caught that one for me, please. Okay, so I'm just adding 16 to get rid of the 16, the negative 16. I'm adding 16 here onto the 2, so that will give me 18. Okay, so there's a general equation for me, but remember what I've got to do is I've got to change it into the letters that I'm going to use in my graph. So for fuel economy, I'm just going to use an F. So F is equal to, and it'll be minus 2, and for the engine size, I'm using E, and that's plus 18 that's there. Okay, and probably what I could see from the graph, if I've got an 18, that's where I should be cutting through the y-axis, or in this case, the f-axis. And that looks like it's going to be hitting through 18 that's about there. Yeah, so pretty close to that. Right, I'm going to use that equation to work out the fuel consumption that I'd expect to see on a 2.2 litre car, based on this information that we've got. It's just limited data, but based on that. Right, so what I'm going to use is I'm going to use this equation. And from there, what we're going to do is we're going to substitute the 2.2 litres in where the engine size is. So I've got minus 2 times 2.2 plus 18. So that's going to give me, when I multiply that, 4.4 plus 18. So the way I can think about this one is I can either start at minus 4.4 and add 18 on, or I can think about 18 and I can take 4.4 away. And what that's going to leave me with is going to be 13.6. And 13.6, we're talking about kilometres per litre. So that'll be kilometres per litre. And that's for a 2.2 litre car. Okay, so what we've covered here is we've covered how to go about drawing a scatter graph from a data table. We've then got a method to work out how to draw our line of best fit. So the method I've shown you is working out the mean point. All you need to do is make sure that you can cut that data in a reasonable way using a straight line and the line of best fit. Okay, the data point just helps swivel that ruler around. We're then finding the equation of the line of best fit, and we've usually always got to use the letters that's given. You know, sometimes it might be y and x, but more often than not in exam questions, it will be different. Make sure you change it. If you don't, a mark's gone from there. And then we're going to have to use that equation to work something out. Even if you can see the value, don't just write the value down. You must show the use of the equation. Okay, right, so that's the way we would do this at National 5. At National 4, all we do is read the graph. We draw the line the best fit in, and we would read up and along. National 5, equation. Must use the equation. Okay, so this links in really well with the work that you've done on straight line and the work that you've done with equations and changing the subject to the equation. So that's about us for this straight line topic so far, and we'll get on with some exam questions now.